this is why we need to know about the midterm and the max term. Okay, here I add a note here. So a Boolean function can be expressed maybe at this algebraically from a given truth table. By forming a min term for each combination, of the variables that produce a 1 in the function and taking the OR of all those terms, Okay, let us see what it means with one example. Okay, so you have one function, which is the function is f1. So I choose the, okay, so you want to take a look to this. Okay, so see, let I read that again for you. A Boolean function can be expressed from a given truth table by forming a midterm for each combination of the variables that produce a 1 in the function and taking the OR of all those terms. So what I try here to say, this is what we want to learn. If you have a truth table of a function, Boolean function, you just take a look to the row that the function is 1. So then you could actually represent that function by adding or ORing that terms that we have on that truth table. Example will be more clear. So let's explain that with one example. So example is this. Example says f1 equal to x prime y prime z plus x y prime z prime and plus x y z. Okay. So the first question is, if you want to write this function, the first thing is the function has 3 variables. Okay. So if you want to write this function based off the midterms, so the first question is, what is the first term if you want to write based off the midterm? This is which midterm? This is midterm 0, 1, 2, 3. Definitely you will have 7, right? Whenever you have 3 variables, you could make 7 midterm, 7 max term. Okay. So now the question is, what is this term is midterm 0, 1, 2, which one? Should be M. You tell the index 0 to 7. You have an option between 0 to 7. What is M? X prime, Y prime, Z. So you back here. What is X prime, Y prime, Z? Okay, so that means this pin 0, which is got the prime, right? This pin 0 got the prime. This is 1. It should be M1. So back to the M1, and C M1. So I'm talking about the midterm, not max term. Okay, so midterm. So see if this is 0, 0, 1, the term for M1 is x prime y prime z. So back here x prime y prime z. Even it's more simple, you say, okay, this should be a midterm because you apply the AND, right? So the format of the midterm is C apply the how would we tell if it is the minimum or max term? So definitely this is how you could, if you take a look to this, so you should tell this is a midterm or max term. Definitely this is a midterm. Why? Because you apply the AND between three variables. Okay, if that's max term, should be in the form of x plus y plus z, not x, y, z. Okay, so that's why you see here and you know, okay, this is a mid. If that's max term, it should be x plus y plus z. So because whenever you want to make the midterm, the first step is apply the AND between three variables. Whenever you want to make the max term, the first step is apply OR between three variables. So as you could see here, here is x, y, z. Definitely it could be midterm, not max term. So I don't know, this is your question. Yes or no? Okay. So definitely this is a midterm. So the number, so definitely you say the number should be, this definitely will be 0 in that row because it's get the prime. This being 0, which has got the prime, and this is 1. So what is the 0, 0, 1? M1, right? So I write M1 plus. What is this? This is what's M, which midterm? 4. So definitely you say same thing. 0, 0, 1, that pin definitely is 4. If you don't believe me, back to this table and check the M4. So see x, y prime, z prime. Okay, x, y prime, z prime. Okay. And what should be the last one? Should be M7. Okay. So nothing new. You had one function which has 3 terms. You actually change that terms to the mid. But what I here put as a note is this one. Let we actually draw the truth table for this function. Remember, we learned about the truth table, right, in our previous class. So if I want to make a truth table for function f1, so you tell me the truth table of the function f1 should have how many rows? How many rows I should have in truth table of f1? That was the topic of our last class. For truth table, left side, you actually list, yeah, definitely 2 power 3 is 8. So you list the all possible value that you could have in your input, right? So this is the first step in the truth table. I just separate this truth table here. Okay, so the next should be this, and the next should be this. Okay, so you list all 8 cases that you could have, or we say start from the 0 to 2 power n minus 1, which is 8 minus 1 is 7. You list all of them. Okay, this is the left side of the truth table. So let's make the right side. In the right side, usually you have the function and shows what the f1 get for each of these variables. Okay, so whenever it is 330, you just back here and you put the z, you replace x with 0, y with 0, z 0, and find these 3 terms. Then whatever you got, it should be the value for f1. Okay. So if you do that, so suppose I did that, I end up with this truth table that you see. Okay. So here 0, here 1, here 2, 0, and 1. Okay. So this is truth table for this function that you see, which you already know how you could get this table, this truth table. But What is important here, just check, see where this function is 1. So what is this mid, if I consider as a midterm, what is this row should be which midterm? What's the number for this midterm? Should be M1, right? How about this? This is which M? This is M4, okay? And how about this, which is function is 1? So this is M7, okay? So this is what I try to tell here. So that means whenever you have the truth table and the midterm that you have, technically these are the cases or the rows that the value of this function is 1, okay? So that means in these 3 midterm or in 3 row, the function is 1. In the other places is 0. Okay. So that's what we try to tell here. A Boolean function can be expressed from a given truth table. So that means if you have the truth table of these F1, so you could actually, from the algebra point of the view, you could write that function. How? You just check the rows, and in which row the function is 1, you need to say, okay, that function is that minterm and you or that minterm. Usually we could write this in this way, that we have sigma m, just put the number of the midterm, m47, okay? So that means whenever you see f1 equal to sigma m147, definitely you know if you draw the truth table in this midterm or in this row, the function is 1. It has the opposite side. So that means if you have the function truth table, definitely you could write the function in Boolean algebra with using these midterm that you have. You say, okay, it's a or between the all midterms, which is function is 1, right? Which is M1, M4, and M7. Okay. So it has the other side too. So how about the max term? If I write this as a max term, so let's see how we could do that. For doing that, I'm changing whatever we have here. I'm not going to rewrite these nodes, just make the changes if you want to change or write your function based off the max term, okay? So a Boolean function can be expressed algebraically from a given truth table by forming a, so if you change this, it could be second node, okay? Suppose this is node 1. For node 2, you just change these midterm to max term, okay? With forming a max term for each combination of the variables that produce a, you need to change 1 to 0, okay? In the truth table and the table, the or of all those terms. So here you need to change the or and you say and of, or and of all those terms. So let's see what it means in this table. So I want to write this based of the and of the max terms, okay? So see and of all those terms that the function is 0. You need to check where this function is 0 here. What is this number? This is max term 0, right? Max term 0. What is this? This is M2. What is this here? I could say this is M3. So I don't want to write this. So this is M5. I'm just interested where the function is 0, right? So how about this? This is M6. That means I could say this function equal to the max term 0 time max term 2 time max term 3 time max term 5 time max term 6. Okay, so yeah, you could use this sample to actually rewrite whatever you see here. So which is, you could just write the number of the max term 0, 2, 3, 5, and 6. Okay. So let I summarize that for you, okay? So whenever you have truth table truth table of the function, you could write that function in Boolean algebra based of actually sum of the midterm or product of max terms. So sum of the midterms, the midterms that function here is 1, so which you see 1, 4, and 7, and which max terms, the max terms that function is 0 in that max term, which is 0, 2, 3, 5, and 6, okay? So even when you have one form, you could write the second form, okay? How? Here you have 1, 4, 7. So you say should be the max term that the number is not here, which is 0, 2, 3, 5, and 6, okay? So let I actually have one more example, which is the other function here. You have f2, which is a function in Boolean algebra. And this is the function. So the function is, let's do the opposite of that, okay? So let's do the opposite of that because we did this here. So let's do the opposite of that. Suppose you have a function and you have the truth table of the function. So let I give you a truth table. You actually give me the function, okay? So the function name is f2. So this is a truth table for that. So as you expect, it actually has 8 rows. So I list all of them. So this is 2, 0, this is 2, 1, this is 2, 0, this is 1, this is 0, 1, 0, 1, 0, 1, 0, 1. So the truth table says this. The function actually, whenever you have in these 3 rows is 0, 0, then you have 1 here. So then again, you have another 0 here, and then you have 3, 1, okay? So the question is write that function in the Boolean algebra and tell me what is that function in Boolean algebra, how you could actually represent this function in Boolean algebra, okay? So definitely based on what we have here or what we learn here, you could actually tell I could write this function in Boolean algebra to 2 different ways. The first one is sum of the midterms, right? Sum of the midterms. So see sum of the midterms, which we should fill out the midterms here, okay? Or I could actually write this based on the product of the max term, right? So let's see how many we need. Definitely we need 4. So that means you need to fill out the max term between these dots, okay? So let's start with the midterm. So this F2 is the sum of the which midterms. You just give me the numbers, which midterm. So this is what we try to learn. You take a look to the truth table. You say the sum of the midterm that the function is 1. So you have this. What is this midterm that you see here? What its number? Should be m. What is the number of the midterm? So let I spread this, maybe help you to see what we have. Okay, so we have one answer in the chat box. M3. So M3, yeah, you just take a look to the binary numbers that you have. That's actually these equivalent in base 10, which is 3, right? Definitely you have 3. Or you could actually write M3. You already know how you could write the M3. The M3 is what? X should be 0, which is prime, x prime, y, z. So the both is the same thing. Okay, I could write M3 or write x prime, y, z. How about the next one? So next one, take a look, see where function again is 1. What is this number here? Because here the function is again 1. So what is this number, midterm number here? Type on the chat box, M. I write the M, you give me a number. So definitely we don't need the last one, we have just 4. Okay, so we don't need this. Okay, what's the number? M4. So let's see, what is this? I change this here. Okay. Okay, so I still that's eraser. Okay. So what is this number? You just take a look to the, what is the 101 is 5, right? So definitely you say M5. Okay. What is the next one here? You have it 6. You could say 6. What is the next one is 7. You say 7. So you could write, this is another form. What is the M5? So that means these are the skills that you should have. You should switch between these two very fast because you already know how you could write the M3. What is the M5? First, apply the AND operator XYZ. So you have 5. What is the 5? 5 is 1, 0, 1. So the 0 get the prime and these two not get the prime. So that means this is XY prime Z. M6. What is the 6? Is 1, 1, 0. So that means XY don't get the 0, Z get the prime. Okay. M7 is XYZ. All of them is 1, no prime. Okay. So that means F2 is this or equal to whatever you see. That means you could write the function in Boolean algebra based off the truth table that you have. Okay. Any question about the first one, which is the sum of the midterms? So the opposite of this again is right. If I give you this, if I say you F2 equal M3, M5, M6, M7, definitely you know how you could draw the truth table. You just, this part is obvious because all the time is same whenever you have the function with 3 variables, and then you back take a look to these cases that you have and say this in this row the function should do 1. You put the 1 and the rest should be 0. Okay. So similarly, you could actually put the M7. So sorry, base of the product of the Mach term. So you just, for the writing in the product of the Mach term, you just take a look and see where the function is 0. Okay. So here the function is 0, so you could say M0. Here the function is 0, which is M1. Here function is 0, which is M2. So here the function is 0, which is, this is 5, right? So you have M5, that's it. So even if whenever you have this, you could write this form, right? Why? Because whenever the function is 1 in 3, 5, 6, 7, definitely it's 0 in 0, 1, 2, 5, right? So whatever you don't have between 0 and 7 definitely should be here inside this. Or you could actually write this. This is equal to the same thing that I'm writing here. Sorry, product of Mach terms. So I'm writing the X Mach terms here. I have 4. I put 4 parentheses. X Mach term is apply the OR. I apply first the OR between 3 variables. So M0, so that means all of them would be 0, no prime, right? So 0, no prime, 1 get the prime in the Mach term. M1, again, you put x plus y plus z. 1 is 1, 0, 0. Which one get the prime? This one get the prime. So then M2, again, you say x plus y plus z. What is the 2 is 1, 0, 0. Which one get the prime? The y. So then 5. 5, again, you say x plus y plus z. So 5 is 1, 0, 1. Which one get the prime? These two get the prime. Okay? So that means if I give you any function, and its truth table, you should be able to write that based of the sum of the midterms or product of the max terms. Okay, product of the max terms.